So in this question, we've got a ball which falls to the ground from this point here. And when it reaches point M, it's travelling at u meters per second. When it gets to point N, it's travelling at 3 times that speed, at 3u meters per second. We've got a height here, h, and we've got acceleration drawn on the diagram already. Now, as the ball falls to the ground, we've got motion is due to gravity only, and acceleration is constant. So we want to find the time to travel from M to N, so that's this distance, and show that the height is greater than 4u squared over g. So we're going to show that that height is at least that. So when you see constant acceleration in the question, this looks like a kinematics question and using the SUVAT equations. So what I'm going to do first of all, I'm going to write the SUVAT letters, the 5 letters on here, and see what information we've got. I've got S, U, V, A and T. So I've not given any numbers, so this is going to be an algebra question. So S, that's the displacement. Well, that's going to be h eventually, so we'll have a look at that in a moment. U is the initial velocity. Well, if we're looking at the time to travel from M to N, our initial velocity is u meters per second, so that would just stay as u. Now V is the time to travel to N, so that's the velocity that we're interested in after a certain amount of time, which is 3u. So I can write that there as 3u. Acceleration. Acceleration is constant and the motion is due to gravity. So therefore acceleration I can write as the gravitational constant g. And time, well, in part 1 that's what we want to find. So we want to find what time is. So for that equation we can use the velocity equals the initial velocity plus acceleration times time. And that way then we can get some sort of equation for time. So V is our velocity, so that's 3u, and that equals u plus acceleration. Well, acceleration is g, and multiply that by time. So what we want to do now is get t on its own. So let's bring the u over this side. So that gives me now 2u, and that equals g times t. And now divide both sides by t. I get t equals 2u over g. So that's an equation for time travel from there to there. So therefore t equals 2u over g. So that's good, that's the first part taken care of. Now we need show h is greater than 4u squared over g. So for this part, let's go again with the SUVAT equations. That's my calculations for part 1. I can leave that in a box on its own. Part 2. So show the height h is greater than 4u squared over g. Well, we know this information, and we know h is greater than that. So that looks like the information that we need to do. So S is show the height, so that S is the displacement, so that's what we need to find. U again and 3u we know, so that's u and 3u. Acceleration is g, and t is 2u over g. Okay, so we've got that information to find that. So therefore for that we can use the SUVAT equation in part 2. V squared equals u squared plus 2as. And let's work with that. So v squared, so that's 3u squared. That equals u squared, which is just u squared. 2 times acceleration, which is g. And the displacement, which we need to find out. So that's what we need to put in there. Okay, now let's simplify this off. So we need to try and get S on its own. So we've got 9u squared equals u squared plus 2gs. Right, let's get u squared on this side. So now I've got 8u squared 2gs. Right, now I can divide both sides by 2g. So now I've got, divide that by 2g, divide that by 2g, and then I'm going to get s on its own, and then this 8 and 2 can cancel, give me with a 4. So now I'm left with this distance here, mn. So if I write here, mn equals 4u squared over g. That's the displacement from there. But we want h. So we know h is bigger than that. So h is greater than mn 4u squared over g. So therefore h is greater than 4u squared over g. And that takes care of that.